on two different yeasts. Now, I'm sure you are aware of Saccharomyces cerevisiae, right? That's a yeast that has been worked with all over the world for last several decades, and it's been one of the best genetic model system to answer many basic questions in biology. The other system that I'll just come in a minute. So the title, of course, is working with two yeasts. The good yeast, or conventional yeast, which is Saccharomyces cerevisiae. I'll tell you why we call it conventional. And the non-conventional, that is sort of a bad yeast, which is Candida albicans. And are you all familiar with Candida albicans? Yeah, okay, great. So I can reduce my introduction a little bit. Okay, so Saccharomyces cerevisiae is a budding yeast. So Saccharomyces cerevisiae is a budding yeast, and evolutionarily, Candida albicans and Saccharomyces cerevisiae are not very closely linked, although both of them are budding yeasts. Their genomes, and you may know Saccharomyces cerevisiae. What is the peculiarity of Saccharomyces cerevisiae genome? You know, Saccharomyces cerevisiae was the first eukaryotic genome to have been completely sequenced. Okay, and obviously the reason why it was chosen was because it's a eukaryote, and it's a very simple system where genetics have been very well worked out for last several decades, right? So there are lots of tools to manipulate the system, have been available for several years. And Candida albicans I'll come to a little later. Here you can just see the comparison between Saccharomyces cerevisiae and Candida albicans in terms of their life cycles. What is interesting is the cerevisiae, which in nature is in diploid form, can undergo, under certain conditions, meiosis, gives rise to haploid spores. Then again the haploid spores mate and then become diploid. Once it is diploid cells are very sturdy and they remain going through mitotic cycle. Candida albicans, on the other hand, is a guy who is stuck in diploidy only. Okay, so it cannot undergo meiosis, although recent literature says that there are genes which are involved in meiosis which are present in Candida. Nobody knows why it doesn't show meiosis. Okay, and there are some related projects that I am working on where we have fused Candida albicans with another diploid Candida species. It's called Candida dubliniensis. Okay, dubliniensis is not very pathogenic. Candida albicans is quite pathogenic, and we fused it, and we made chromosomes of this tetraploid yeast to be lost, and then we made the yeast in such a way that it will have only one set of albicans DNA chromosomes and one set of dubliniensis chromosomes. In principle, then it is haploid with respect to either of the species, and then we have started looking at what the properties of this organism is, and we have some interesting studies, but I'm not going to talk about that much. Cerevisiae and albicans, there are genomes are comparable, the number of genes are also comparable. Chromosomes are slightly different. Albicans chromosomes are larger, smaller in number, and so on. Now, for several years, in fact during my postdoctoral work, I worked on understanding the mechanism of transcription in Saccharomyces cerevisiae.